relaxes you, distresses you. Okay. So you threw a rock at 4 meters per second. So you can see your diagram, 4 meters per second at an angle of 40 degrees. Can you see it's theta? That is theta with respect to the x-axis. So I'm hammering that to make you remember that is our idea of theta. All right? So there are two questions here. When will it get to the highest point? And then how fast will it be moving at that point? Okay? I'd like to start out with second question because that's easy, right? Do you recall we talked about this is now an angled vector, correct? So it has a VIX over here, right? And it has a VIY up there. So the VIX component will proceed without any acceleration. And that's why if you have an arrow here to represent VIX, it's going to be the same all throughout the object's motion. That makes sense? I showed you that diagram before. Now, VIY, which is the projection vertically right here, is affected by gravity. So it will be accelerated by gravity, which is in the downward direction. So we remember that as it moves up, it loses by 9.8 meters per second every second, right? And stops at the highest point. So you can imagine the vertical projection getting smaller, smaller, smaller until it's 0 at the highest point. And then on its way down, it's going to increase by 9.8 every second. Does that make sense? Okay? And therefore, if it loses that projection here at the highest point, then the velocity here is simply whatever is the projection along x. Correct? Okay? So the final velocity at the maximum height is mainly from the x component, which is VIX component, which is 4 meters per second cosine 40 degrees, which is this. Okay? Now, I sometimes see people saying the velocity here is 0. No, because if it is 0, it will just drop straight down. Okay? There is still some velocity that will enable it to move in a forward or horizontal direction. Okay? So that takes care of this part right here. Now, the first part is, when will it get to the highest point? We did say that projectile motion is a combination of horizontal and vertical motion, which are independent of each other. So can't we just analyze that y component that eventually stops at the highest point and use that information to solve for the time to reach the highest point, right? So isn't it true that the final velocity when an object is accelerated is equal to initial velocity plus the product of acceleration times time? Now we're relating it to y components of this projectile. So this is VF y component, VI y component, acceleration along y is gravitational acceleration. This happens to be 0. We just explained why. And this is your initial velocity along the y projection, okay? Plus your negative direction for acceleration times the time to reach maximum height. So here is your time. You plug it back here. Where is it? No, we don't. Okay? That's the only unknown here.
Yeah, I was a little bit confused because I was saying when does it mean that that's the question on the time or the
when is time? When?
So yeah.
When is time?
I calculated both.
Okay.
All
All right.
When is time, right? Yeah.
Other things I want to talk about. If it takes 0.26 seconds to get here, how long will it take to get here, which is, the same level? Just multiply it by 2. There's symmetry here, right? It will take 0.26 seconds to reach the highest point, and also 0.26 seconds to get all over here. Okay? So there is symmetry right here. All right, if I also ask you, right here is at the same level, right, with which you projected it. How fast is the object going here? Think very carefully. How fast is it here? 4 meters per second. How fast? It is just a scalar, okay? But clearly it will be 40 degrees below the x-axis. It will be the same speed. All right? Questions? All right, do you mind turning that off? Thank you.
So
All right.